Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice math Olympiad geometric challenge, and here we have a right triangle which is inscribed or which is fully inscribed in a square ABCD, and here our claim is to find the area of this triangle BEM. So here some information we are given is that because this is the square and the one side length of the square is 8. So I think so you already know about the square because all the sides of the square are equal. So if the one side has length 8, so it means that all the other sides has length 8. So if this is 8, so this length is 8 and AD length is 8, and similarly AB length is also 8. So here you see that this M point be the midpoint of CD, and we have these 2 points are of equal length. So if you have the length of CD is 8 and M be the midpoint of CD, so it means that the length of CM is 4, and similarly the length of MD is also 4. So as well as you will see that we have a right triangle BEM, and you see here the length of two sides are equal, so it means that this triangle be the isosceles triangle. And you very well know about the isosceles triangle, a triangle in which the sides of the two sides have equal length is called the isosceles triangle. So uh, now first we focus on the right triangle BMC, and here you see that ABCD be the square, and you know that all the angles, all the corner angles of the square are of right angle. So this is right angle, this is right angle, and as well as this angle is also right angle. So now first we focus on the right triangle BCM. So here you see that in right triangle BCM, so here you see that this is the right angle, so the side opposite to this right angle is known as the hypotenuse, and the other two sides are known as, if I can suppose this is any angle, so according to this angle, now we say that this side is base and this side is perpendicular. So now first we find the length of the hypotenuse. So now we use here the nice Pythagorean theorem. So according to Pythagorean theorem, you know that hypotenuse square equals to base square plus perpendicular square. So this is known as the Pythagorean theorem. So now if you focus on this figure, and we have here we find the value of h, which is hypotenuse, so we write it as it is, and it is equals to base square. So here our base is cm and it is 4. So here you obtain 4 square plus perpendicular is 8, so we have 8 square. So now we simplify the terms, and you obtain 4 square is 16 and 8 square is 64, and when you sum up these two terms, then you get here hypotenuse square is 80. And now we write this 80 as 60 times of 5. You know that 60 times of 5 is 80, and now we take the square on both of the sides, and you obtain h equals to 16 times of 5. And you know that the square root of 16 is 4, and it will become square root of 5. So this is the value of hypotenuse. So here you have this value will becomes uh, 4 times of square root 5. So we write here this length is 4 times of square root 5. And now in the next step, uh, you focus on this right triangle BEM, and we know that this right triangle be the isosceles triangle, so the length of two sides are equal. So now we again use the Pythagorean theorem in right triangle BEM. So now here we write in a right triangle BEM. So here you see that this is the BEM right triangle. So here this is the our right angle, and this side opposite to the right angle is hypotenuse, and other two are base and perpendicular. So now we again use the Pythagorean theorem, and we write here hypotenuse square equals to base square plus perpendicular square. So this is the our Pythagorean theorem, and now we substitute the values of hypotenuse, base, and perpendicular. So if you focus on this figure, so these two side lengths are equal. So we named this side length as lowercase b, and because these two sides are equal, so it means that this side length is also lowercase b. So now here we first find the value of this b by using this Pythagorean theorem. So here we substitute the values of h and b and p here. So our h will be 4 times of square root 5. So we write it here 4 times of square root 5, and its whole square equals to our base and perpendiculars are equal, and it is equals to b squared. So here you this will be also b squared. So here you see that the square of h square equals to 80. So we substitute the value of h square, it will be equals to 80, and when we add these two values, it will becomes 2 times of b square equals to 80. So this implies that we have the value of b square equals to 40. And now we move towards our conclusion or our claim. So in this question, our claim is to find the area of this right triangle BEM. So you know that what is the formula of area of a triangle? So here I can write area of triangle BEM. So we have the triangle BEM. So the formula of area of triangle is half times of base multiplied by its height. So now you focus on this triangle. So you see that its base is b and also its height is also b. So it means that because this is the isosceles triangle, so that its base and height are same, so we denote it by lowercase of b. So this is also b, and now you get 1 over 2 times of b square. And here we find the value of b square is 40. So now you put this value here and you obtain half times of 40, and when we cancel these terms, then you get here 20 square units. So this is the area of the given right triangle, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.